Hello, dear students. Welcome to this lecture. In this lecture, we are going to see Introduction to Fourier Series. So, in this lecture, we are going to focus on the formula of Fourier series and where this Fourier series is applied. So, let's start with this lecture. So, this is the introduction to Fourier series. So, basically, Fourier series deconstruct the complex waves into pure frequencies, a fundamental concept in signal processing, physics, and engineering. So, what is Fourier series? So, basically, this Fourier series represents the given function as an infinite sum of sine series and cosine series. So, here we can see for periodic function representation, Fourier series represents any periodic function as an infinite sum of simple sines and cosines. So we are going to represent the given function in terms of sines and cosines, which is an infinite sum. Then in complex signal decomposition, the periodic signal, regardless of its shape, it can be broken down into its basic components. Now, in the same way, in musical chord analogy, similar to how a musical chord can be separated into its individual notes or frequencies, we are going to deconstruct the series, the given function in terms of sines and cosines. So basically, Fourier series is nothing but representing the given function as an infinite sum of sines and cosines. Now, it is very important to see the Dirichlet's condition when we are going to study the Fourier series. So, any function which can be expressed as a Fourier series that must satisfy this Dirichlet's condition. So, these three are nothing but Dirichlet's condition. So, let's see this condition number one, Dirichlet's condition number one. The given function should be periodic and single valued, and it should be a finite function. So these conditions are very important. Function should be periodic function having certain period. Then the function should be single valued and it should be finite. Second condition says that the function fx has a finite number of discontinuities within a single period. So the function must have or should actually this should be continuous function, or the function has finite number of discontinuities within any single period. And number three, condition number three is the function has at most finite number of maxima and minima. So these three are nothing but Dirichlet's condition. Now function can be represented as a Fourier series if this function satisfies these three Dirichlet's conditions. Otherwise, we cannot find Fourier series. So here, these two examples we can see. If we consider fx is equal to tan x in the interval 0 to pi, then for this particular function, we cannot find Fourier series because we know that pi by 2, of course, this pi by 2 point belongs to this interval 0 to pi. And if we check function value, then f of pi by 2 will be tan of pi by 2. And tan pi by 2 is nothing but infinity. And that's why at x is equal to pi by 2, function becomes infinity. So which is, that means condition number 1 is not getting satisfied, and hence we cannot find Fourier series for tan x in the interval 0 to pi. Now see the second example, fx is equal to sine inverse x. Now sine inverse x, basically this is a multi-valued function because we know that sine inverse, if we consider sine inverse 0, then the values of sine inverse 0 are 0, pi, 2 pi, and so on. In general, n pi for any positive integer. So this is basically a multi-valued function. So this again condition number one is not getting satisfied. This is not a single valued, and hence for sine inverse x we cannot find Fourier series. So it is very important to satisfy this Dirichlet's condition for any function f. So these are the Dirichlet's condition. Now let's move to actual formula Fourier series. So here we can see general Fourier series formula, but the interval is c comma c plus 2l. So suppose the c comma c plus 2l is the given interval and we have to find out Fourier series. So as we have just discussed that Fourier series is nothing but representation of the function as a infinite sum of cosines and sines. So see the formula of Fourier series. Fx is equal to a naught by 2 plus summation n running from 1 to infinity an cos n pi x by l plus bn sin n pi x by l. So we are going to express this fx as in terms of sines and cosines. So this a naught, an and bn, these are the coefficients to be determined by using some integration formulae. So this a naught is called as a DC component and the formula of a naught is 1 upon L integration c to c plus 2L fx dx. So within this given interval c and c plus 2L, we are going to find out this integration of the function into 1 upon L. So this is how this DC component a naught can be determined. Now, see an, which is a cosine coefficient. So, an formula is 1 upon L integration within c to c plus 2L of fx into cos n pi x by L into dx. So, this is a cosine coefficient. Now, sine coefficient is Bn and its formula is given by Bn is equal to 1 upon L integration within the given interval c plus 2L of the function fx into sine n pi x by L dx. So for a given function, first we need to find out these coefficients a naught, an, bn by using this particular formula of integration and then substitute this value of a naught, an and bn in this Fourier series. So that will give us representation of the function in terms of sines and cosines. So these are the formula of Fourier series when the interval is c comma c plus 2l. So this is the generalized interval. Now again I have written the Fourier series formula over here and now in the given example we are going to see whether the interval given to us is 0 to 2l or interval given to us is minus L to plus L. So see generalized interval is c comma c plus 2l. Now when we are going to put c equal to 0, the interval becomes 0 comma 0 plus 2l. So that is nothing but 0 to 2l. And for this interval, of course, the Fourier series formula is same for both of these intervals. Only there is slight change in formula of a naught, an and bn. Just this interval will get changed. We can see here. So when the interval is 0 to 2L, A naught formula will becomes 1 upon L integration 0 to 2L because that's our given interval. So this integration within the limit 0 to 2L fx dx, which is formula of A naught, an is equal to 1 upon L integration 0 to 2L, again the given interval, into of fx cos n pi x by L dx and bn is equal to 1 upon L integration 0 to 2L fx sine of n pi x by L dx. Now when we are going to substitute c equal to minus L, the interval becomes minus L to plus L. So this is the interval and again we need to find the coefficients. DC component A naught is equal to 1 upon L integration. Now we can see the limits are minus L to plus L, which is the given interval of fx dx. An is equal to 1 upon L integration minus L to plus L fx cos n pi x by L dx and the sine coefficient bn is equal to 1 upon L integration minus L to plus L fx sine n pi x by L dx. So this is how we have to apply the formula whenever the given interval is 0 to 2L or minus L to plus L. And after finding this A naught, An and Bn, substitute all the values in this Fourier series formula for the final representation. So now why this Fourier series is important? So basically this Fourier series plays a vital role in signal processing, signal analysis. So, in signal processing, Fourier series is essential for noise reduction, audio compression, and data filtering. And also in image processing, we can means the Fourier series is used. So basically, by Fourier series, we are getting the series in terms of sines and cosines. So this is very important tool in signal processing. So in this video, we have seen what is the Fourier series. Now, in coming videos, we will see the examples. Then we are going to see how the even odd functions and how to represent the Fourier series representation for even and odd function. So keep listening the videos. Thank you so much.